Okay, hi everyone, welcome back to this video series on data centers. Source address SA. The SA is a 48-bit MAC address used to identify the transmitting device, and it uses the LSB first. Broadcast and multicast address formats are illegal within the SA field. Length or type 802.3 uses the length field, but the Ethernet Ethernet 2 frame uses a type field to identify the network layer protocol. 802.3 cannot identify the upper layer protocol and must be used with a proprietary LAN IPX, for example. Data. This is a packet sent down to the data link layer from the network layer. The size can vary from 46 to 1500 bytes. Frame check sequence FCS. FCS is a field at the end of a frame that's used to store the cyclical redundancy check CRC answer. The CRC is a mathematical algorithm that's run when each frame is built. When a receiving host receives the frame and runs the CRC, the answer should be the same. If not, the answer is discarded, assuming errors have occurred. Let's pause here for a minute to take a look at some frames caught on our trusty network analyzer. You can see from the first frame below has only three fields: destination, source and type, shown as protocol type in this analyzer. Destination 0060F500-1F27, source 0060F500-1F2C, protocol type 0800IP. This is an Ethernet 2 frame. Notice that the type field is IP or 0800, mostly just referred to as 0x800 in hexadecimal. The next frame has the same fields, so it must be an Ethernet 2 frame 2. Destination FF, Ethernet broadcast, source 02070122DEA4, protocol type 8137 netware. I included this one so you could see that the frame can carry more than just IP. It can also carry IPX or 8137H. Did you notice that this frame was a broadcast? You can tell because the destination hardware address is all ones in binary, or all F's in hexadecimal. Now pay special attention to the length field in the next frame. This must be an 802.3 frame. Flags 0x80, 802.3, status 0x00, packet length 64, timestamp 12:45:45:192:00006:26998. Destination FF, Ethernet broadcast, source 080011075728, length 34. The problem with this frame is, how do you know which protocol the packet is going to? Now just bear with me here for a second. After losing where I am. The problem with this frame is, how do you know which protocol the packet is going to be handed to at the network layer? It doesn't specify in the frame, so it must be IPX. Why? Because when Novell created the 802.3 frame type before the IEEE did and called it 802.3 raw, Novell was pretty much the only LAN server out there. So the folks at Novell assumed that if you were running a LAN, it must be IPX, and they didn't include any network layer protocol field information in the 802.3 frame. Let's take a look at one more Ethernet 2 frame. You can see that the Ethernet frame is the same Ethernet 2 frame we use with the IPv4 routed protocol. The type field has 0x86DD when the frame is carrying IPv6 data, and when we have IPv4 data, the frame uses 0x0800 in the protocol field. Destination IPv6 neighborhood discovery 00010003 333300010003. Source a open 3E7FDD 0001803E7FDD type IPv6 0x86DD. This is the beauty of the Ethernet 2 frame. Because of the type field, we can run any network layer router protocol and will carry the data because it can identify the network layer protocol. 802.3 and SNAP 802.3 Ethernet frame cannot by itself identify the upper layer network protocol. It obviously needs some help. The IEEE defined the 802.2 LLC specifications to provide this function and more. Figure 3.4 shows the IEEE 802.3 with LLC 802.2 and the SNAP. The LLC header information is added to the data portion of the frame. Now let's take a look at an 802.2 frame and SNAP captured from our analyzer. Destination SAP AA, source SAP AA, CTRL 03 OUI ID type data, destination SAP, source SAP, CTRL data. 802.2 frame. The following is an 802.2 frame captured with a protocol analyzer. Flags 0x80802.3, status 02x02, truncated packet length 64, slice length 51, timestamp 12/24/00/592/000/03261998. Destination FF Ethernet broadcast. Source 0080C7 A8F03D LLC length 37. Destination SAP 0xe0 Netware. Source SAP 0xe0 Netware individual LLC sublayer management function. Command 0x03 unnumbered information. You can see that the first frame has a length field, so it's probably an 802.3, right? Maybe look again. It also has a destination and source service access point, DSAP, and an SSAP, so it's not an 802.3. It has to be an 802.2 frame. Remember, an 802.2 frame is an 802.2 frame with the LLC information in the data field of the header. So we know the upper layer protocol is the SSAP and DSAP. Define the network layer protocol, source and destination. It will be rare to see these fields define anything but IP and IPv6 in today's networks. SNAP frame. The SNAP frame has its own protocol field to identify the upper layer protocol. This is really a way to allow an Ethernet to Ethernet type field to be used in an Ethernet 02.3 frame even though the following network trace shows a protocol field, it is actually an Ethernet 2 type ether type field. Flags 0x80802.3, status 0x00, packet length 78, timestamp 0324826400001 0104 802.3, header destination 090007 ATPH2, broadcast source 00008610C1 6F LLC, length 6802.2, logical link control LLC, header destination SAP 0xAASN snap 0, source SAP 0xAA snap, command 0x03, unnumbered information protocol 0x08000789 Apple Talk. You can identify a snap frame because the DSAP and the SSAP fields are always AA, and the command field is always 3. This frame type was created because not all protocols worked well with the 802.3 Ethernet frame, which didn't have an ether type field to allow the proprietary protocols created by an application developers to be used in the LLC. The IEEE defined the SSNAP format that uses the exact same codes as Ethernet 2 up until about 1997 or so. The SNAP frame was on its way out of the corporate market. However, the 802.11 wireless LAN specification uses an Ethernet snap field to identify the network layer protocol. Cisco also still uses a snap frame with its proprietary protocol, Cisco Discovery Protocol CDP, but you won't find SNAP in today's Ethernet LAN networks. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.